So picture this. You're waking up, and it is finally the first genuinely chilly morning of fall.
Oh, the best feeling.
Right. You finally walk over to the thermostat, you flip it over to heat for the first time all season, and you wait. Or, alternatively, flip the scenario. It's mid-July, the AC is just roaring constantly to fight off this massive heat wave.
Working overtime.
Exactly. And suddenly, in either situation, the whole house starts to smell like something is on fire.
Oh, that is just the worst feeling. Total panic.
It's an instant stomach-dropping moment because, human beings are literally biologically hardwired to panic at the smell of burning, right?
Oh, absolutely. Our primal instincts kick in immediately. That smell gets categorized as an immediate, life-threatening danger way before our logic even has a chance to catch up.
Yeah, but the problem is, standing in your modern living room, that primal panic response kind of misfires a lot of the time.
It really does, yeah. Because modern residential HVAC systems, they produce this massive spectrum of odors that can mimic a house fire, but the actual mechanical reality behind those smells varies wildly.
Which brings us to our mission for today's deep dive. We're going to build a technical filter for that panic. We're going to map out exactly what is happening mechanically when you smell these things so you, the listener, can figure out exactly when to initiate emergency protocols and when you just need to open a window.
It's all about knowing what's actually happening inside the sheet metal.
Right. And to do that, we are pulling our operational data from a fantastic source today. We're looking at the field notes and the comprehensive guide from Dave Hartzell.
Yes, Dave really knows his stuff.
He does. Dave is the owner of Hartzell's Heat and Air in Kingfisher, Oklahoma, and he is a NATE-certified master HVAC technician. Plus, he has exactly 47 years in the trade. So we are relying heavily on that specific, localized expertise to break this down.
47 years in the field, you've seen the complete life cycle of every possible mechanical failure out there. So the way we're going to tackle this is by categorizing these scary smells into, basically into buckets.
Okay, buckets. I like that.
Yeah, ranging from totally normal operation all the way up to absolute literal emergencies. And we're going to keep the focus strictly on how the equipment works and what a homeowner can actually safely check themselves.
Perfect. So let's start with the baseline scenario, the one that triggers, all those false alarms every autumn, the harmless scare.
Ah, yes. The dusty burn-off.
That's the one.
Yeah.
That hot, scorched dust smell filling up the ductwork during the very first heating cycle of the year. I know the basic idea is just dust burning, but mechanically speaking, why is it so intense? Why does the whole house smell like it?
Well, it comes down to a massive, instantaneous thermal shock. So think about the idle summer months. Your system's evaporator coil is doing all the cooling work, right? But the heating components, so the burners, the heat exchanger, they're just sitting there dormant in the dark.
Just collecting dust. Literally.
Literally. A thin layer of particulate matter settles over the entire exterior of that heat exchanger. And we're talking standard household dust, pet dander, whatever's in the air.
Okay.
So when that first cold snap hits and your thermostat finally calls for heat, the system fires up, the gas valve opens, the igniter fires, and those burners blast a flame that drives the internal temperature of that metal heat exchanger up by hundreds of degrees in just seconds.
Wow. Okay. I kind of always picture it like, when you have a toaster that's been sitting on a dusty back shelf for a year.
Yes. Perfect analogy.
And you plug it in and push it down, and it instantly smells awful because all that accumulated dust on the heating elements just fries all at once.
That is exactly what's happening, just on a much larger scale. The metal gets incredibly hot, incredibly fast, and that dormant layer of dust just vaporizes. It's a flash-off. And then, of course, the blower motor kicks on and pushes all that vaporized, scorched dust through the vents into every room.
So it smells terrible. But what's the tell here? How do I know it's just the toaster analogy and not my house actually burning down?
The defining characteristic here is that it fades. It should be a relatively mild burning smell, and it should noticeably dissipate within about an hour because, there's only a finite amount of dust on the unit. Once it burns off, it's gone.
Right. The fuel source is gone.
Yeah.
So the only homeowner action required here is just crack a window, let it air out, and just wait it out.
Exactly. Just let it cycle.
But fading is the key word there. What if it doesn't fade?
Mm-hmm.
What if the smell turns really sharp or acrid? Because that shifts us right into Dave's second bucket, which is electrical warning signs.
Yeah, that's where things get serious. If the smell doesn't drop off or if it changes into a synthetic chemical smell, we are out of the harmless dust zone.
Right. And looking at Dave Hartzell's notes, he lists some very specific odors for this bucket. Hot plastic, a sharp electrical ozone smell, And this one threw me a strange fishy smell.
The fishy smell is always the one that catches people off guard.
Yeah. I mean, why would my vents smell like dead fish? What is mechanically happening there?
So this all points to electrical components getting way, way too hot. Specifically, we're talking about the insulation wrapped around the wiring melting, or a motor starting to fail, or a part called a capacitor going bad.
Okay, but how does melting plastic smell like fish?
It's the synthetic plastics and polymers used to coat the wires. They're designed to handle standard heat. But if there's excessive electrical resistance, like a failing part, the wire itself basically turns into a heating element. And as that coating melts and breaks down, it releases chemical compounds called amines.
Amines?
Yeah, and the human nose is incredibly sensitive to amines. And our brains interpret that specific chemical structure as the smell of dead fish.
That is wild. Okay, so if I smell hot plastic or fish, I've got an electrical short or a melting wire. Now, my first instinct as a homeowner, especially if I smell it coming from the indoor unit, is to just grab a screwdriver, pop the panel off, and look for the burnt wire myself.
Oh, absolutely do not do that.
Well, why not? I mean, I can just turn the thermostat to off, right? Just look with a flashlight.
No, and Dave's guide is incredibly strict about this. You have to remember a specific component inside that cabinet called a capacitor.
Okay, what does the capacitor do that makes it so dangerous?
A capacitor is basically a massive potential energy reservoir. Its job is to store up a huge electrical charge to give the fan motor the torque it needs to start spinning.
Oh, so it's like a battery?
Sort of, but it dumps all its power at once. And the
Oh.
danger is that this capacitor can hold a lethal electrical charge long after the system has shut down, even if the power is completely off at the thermostat.
Wait, really? Even if the system isn't running, it's still holding a charge?
Yes, it just sits there fully charged, waiting for a path to discharge. So if you open that panel to go poking around for a melted wire and you accidentally bridge the terminals on that capacitor with your screwdriver, or worse, it will dump that entire stored charge directly through you.
Oh, wow. Okay, I'm never touching that panel again.
Yeah, it's not worth the risk. The strict action plan here from Dave is shut the system off at the thermostat, go out to your breaker panel, switch off the physical breaker to the HVAC unit, and call a professional.
And do not keep running it. Right. Because if you keep it running, you're just feeding more electricity into a melting wire.
Exactly. You're just escalating a fire hazard at that point.
Got it. Okay, so electrical issues give us those sharp plastic or fishy smells. But Dave points out that physical friction creates a completely different, very distinct odor. Which brings us to our third bucket: mechanical strains and choke systems.
Right. Friction generates heat, and heat generates smells.
And the most common one here is the smell of burning rubber. So what's straining to make that smell?
Well, in older systems, it's usually exactly what it smells like: a slipping blower belt. You've got a rubber belt that loses tension, glazes over, and starts slipping on the metal pulley. The motor is spinning fast, the rubber isn't moving with it, and boom, burning rubber smell.
Makes sense. What about newer systems that don't have belts?
In newer systems, it's often a motor bearing seizing up. When the parts that are supposed to spin freely start to drag, they run incredibly hot.
So it's metal grinding on metal.
Exactly. And the action plan is the same as the electrical issue. Shut it down and call a tech immediately. If you catch it early, you might just need a repair. If you let it keep grinding, you're looking at total motor failure.
Okay, but what about a general overheating smell?
Yeah.
Like Dave mentions an odor that doesn't quite smell like rubber, and it doesn't have that sharp plastic bite. It just smells hot, like hot metal.
Ah, yes, the hot metal smell. This is actually where we get an aha moment, because the culprit is usually incredibly innocent.
Really? What is it?
Restricted airflow.
Just
Airflow.
Your HVAC system relies on the air moving through it to carry the heat away from the equipment. If that airflow is blocked, the heat has nowhere to go, so it builds up inside the cabinet and literally starts baking the metal component.
Oh, I see. It's kind of like, imagine trying to run a full marathon while breathing through a really thick, heavy wool scarf. That's a great way to put it.
Right. Your body's working way too hard, you can't breathe, and you just completely overheat. The furnace is doing the exact same thing. It's starving for air.
Yes, and this leads to the one major thing a homeowner can and absolutely should safely check themselves.
The air filter.
The air filter. If you smell general overheating, go pull your filter out. If it is packed solid with dust to the point where you hold it up and you can't see light through it, change it immediately.
Because it's literally acting like a wall in your ductwork.
Exactly. And you would be shocked at how many overheating issues are completely fixed just by swapping out a clogged filter for a clean one. It lets the system breathe again.
That's incredible. Just a simple filter. But there's a limit to this, right?
Oh, definitely. If you put in a clean filter and the smell doesn't go away, and this is crucial, if you ever see actual smoke, your troubleshooting days are over.
Yeah, smoke is a hard stop.
Smoke means active combustion. Shut the power off at the breaker and call a pro. Don't mess with it.
Okay, so just to recap our burning smells so far. Dust burn-off that fades is fine. Sharp plastic, fishy, or rubber smells mean hit the breaker and call a pro. And general hot metal means check your filter.
Perfect summary.
But we have one final bucket from Dave Hartzell's Materials.
Yeah.
And this is a smell that people constantly lump in with burning, even though it requires a drastically different, literally life-saving response.
Yes, this is the ultimate red flag.
We're talking about the smell of rotten eggs or sulfur.
Right. And we need to emphasize this as clearly as possible. This is not a burning problem at all. It is not an equipment malfunction.
No, it's a gas leak.
Exactly. Natural gas is naturally completely odorless. The rotten egg smell is an artificial warning odor, a chemical called mercaptan that utility companies purposefully add to the gas.
So it's designed to smell terrible on purpose so we notice it before the house fills up with gas.
Yes. Our noses are so sensitive to it, we can detect it in parts per billion. It's a highly engineered failsafe.
And Dave's protocol for this is totally uncompromising, right? Like
Yes.
zero troubleshooting.
Yeah. Zero. None. If you smell rotten eggs, you do not go looking for the source of the smell. You don't go sniff the furnace or the water heater.
And you definitely don't flip any switches. That was the part of his notes that really stood out to me. Do not touch a light switch.
Yes, this is so critical. Do not actuate any electrical switches. Don't turn the lights on, don't turn them off, don't adjust the thermostat.
Because a light switch can create a spark.
Exactly. When you flip a normal wall switch, the little copper contacts inside separate, and it creates a microscopic electrical arc. Normally, it's totally harmless, but if your house is filled with a certain concentration of natural gas, that tiny invisible spark behind the plastic switch plate is all the ignition it needs.
That is terrifying. And he even says, don't grab your cell phone to make a call while you're inside the house.
Right. Cell phones have internal relays and static discharge risks. Any potential arc is a hazard.
So the protocol for the listener is just get everyone out of the house immediately.
Immediately. Leave the doors open behind you to let it vent, walk away, and once you are safely outside and down the street, then you call the gas company or 911.
That is such a vital distinction. Do not investigate. Just evacuate.
Clinical action over biological panic.
Wow. Okay, let's do a really quick rapid recap for everyone listening. Dust, burn off, fading away, completely fine, open a window, sharp electrical, fishy, or rubber smells, hit the main breaker and call a pro, general hot metal smell, check your filter, and rotten eggs means evacuate immediately and call from down the street.
That is the perfect diagnostic matrix.
And we really have to thank the source of today's knowledge, Dave Hartzell. Wrapping up this material, Dave actually has a direct message for the listeners today. If you have a burning smell that you cannot explain, just don't gamble on it.
It's never worth the gamble.
No, it's not. You can call Hartzell's Heat and Air at 405-375-4822, or you can book online at hartzellsheetair.com. And again, they are located at 602 South Main in Kingfisher. And, we are talking about exactly 47 years of experience here. That's a master tech who knows exactly how to handle these situations.
Yeah, that kind of field knowledge is just invaluable. It strips away all the mystery of the ductwork and just gives you actionable reality.
It really does. Well, as we wrap up today's deep dive, you had a really interesting final thought on all of this. Something about, our own biology.
Yeah, I just think it's fascinating to mull over. We put all these modern digital thermostats and smart home sensors and Wi-Fi smoke detectors in our houses.
Right, trying to make the house as smart as possible.
Exactly. But despite all that technology, our own biological sense of smell still remains our home's earliest and most effective warning system.
Oh, that's so true.
Our noses tap into this primal survival instinct, right? And they can categorize danger, whether it's melting wires or leaking gas, way before a plastic smoke detector on the ceiling even knows there's a problem.
The ultimate sensor is right in the middle of our face.
Exactly. The tech is great, but human biology still wins.
I love that. Well, thank you all for joining us on this deep dive. Trust your nose, check your filters, and stay safe out there.